Hello there everybody, it's Malcolm Budden here from MMB Networks. This video is going to go over an idea and a concept that I've got about some additional training that we could potentially develop, and it's to see if there was interest in this type of thing. So we're renowned for doing network design training, which is based on real life designs and situations and networks that we've worked on, large scale, small scale, different scenarios, migration plans, things like that. And then of course our CCDE training. What we're looking to explore is if there would be interest in doing something similar based on real life, but more around focused on like network discovery. So how would you, if you were given this network that you see in front of you, how would you quickly determine some common things that are asked to be done? So let me explain what we have here. Is we've got a topology with a Fortinet firewall, a couple of Cisco routers and an Arista switch. So this could signify a remote edge site on a network, and your task might be to find out some things quickly from the network, and this could of course be automated, so we could build this into like an automation script or whatever as well. But sometimes before we get into the automation, you have to actually understand how you would perform the troubleshooting steps or the information gathering steps before you can actually automate it. So this training would be more aimed at entry level or junior network engineers who are just looking to familiarise themselves with finding their way around the network. So let me give you an example here. We have this small topology that I just explained, and we have the IP schema, which talks about like the point-to-point subnets which are between the different environments. Then we have a task list, which is just a set of some basic tasks that might be included within the training in a scenario like this. So the idea would be that you would build your own equivalent topology with your own GNS3 or EVE-NG environment, and then execute these task lists as part of the training. In this task list we're asking to do various different things, and I'm just going to show you how I would approach this. These are things that I just used as an example, so thinking back to my own experience as an engineer and the types of things that you have to do, like identify what a specific device is on the network. So you might see a traffic flow or a firewall flow that something is talking to 10.200.250, but it's not documented what that device actually is. So how do you actually, task one would be, how do you actually identify what device 10.200.250 is on the network, where you start your investigation whilst logged into R1. So let's do that, and what if I was to ask you what is the first thing that you would do? For me, the first thing that you would do is ensure that you have connectivity to the actual IP address. So if we've launched a console from R1, and let's just reset and clear the terminal, and if we can we actually ping 10.200.200.50? Yes, we can ping that. Okay, so let's what would we do next? We have connectivity from R1 on the diagram in the top left that connects to the FortiGate. We have connectivity down to 10.200.200.50, but we don't actually know what that is. So let's have a look and then do a trace route to that particular device, 10.200.200.50. Okay, so we can see that we do follow this path. We go 10.1.2.2, 10.1.11.1, and then we hit the device. So we effectively got 2 hops before we hit the actual device. Now the first hop is 10.1.2.2, so if I do show IP interface brief, 10.1.2.1 is Ethernet 00. Again, this is on R1 here. So 10.1.2.1 is on Ethernet 00, and I've purposely hidden the interface labels on GNS3, because the whole idea with this would be that you would have to figure it out yourself. Now, if I do then something like show IP ARP, you can see that 10.1.2.1 is Ethernet 00, 10.1.2.2, which is the other end of the link, and if I do show IP interface, show RAN interface Ethernet 0/0, I can see actually that the configuration of this Ethernet 00 is in OSPF process 1 area 1. So if I then, you can see that I'm validating the physical layers. First of all, I'm testing that I've got connectivity to the device. Then I check the route that it takes to the device with a trace route. Then I check the ARC table to see or check the interface, IP interface brief, show IP interface brief. And then I check the ARC table to see what else is on that 10.1.2 subnet. And then I've ended up here where I check the interface Ethernet 00 to see if there's any configuration, and going through that process quite quickly, even though it's taken 5 or 6 minutes because I'm talking through it. We've determined that we're probably going to be learning this route from OSPF, right? So if I do now do like a show IP route, actually, if I do a show IP route to 10.200.200.50, I can see indeed that there is a routing entry. The routing entry is it's actually the 10.200, it's a /24 subnet that it resides in, and it's known via OSPF1. There's some different metrics. It's an intra-area OSPF route. And then the next hop is 10.1.2.2 from 10.3.3.3. Okay, so if you know about OSPF and how that works, you'll probably have a good idea. So now that we've established that the route is learned by OSPF, we probably want to do some further digging, and this can be done in a number of different ways, but because I'm showing you, I suppose, the legacy way of tracking down something on the network so that you can then prepare how to automate that process, I'm just going to go and show you how to do it, or how to get to the result that you want to, just going device by device. So we know that it goes via effectively 10.1.2.2, and if I go to the next router and you look, if we go back up to the topology, 10.1.2.2, we don't have the interface names on this diagram, but 10.1.2.2 is going to be one of two devices, or it could be 1.3 actually. It could be the FortiGate, it could be R2, or it could be R3. But in the interests of time, I'm just going to jump to the device that I know that it is, which is R2. And we could actually, before I do that, if you wanted to validate what it was, is then you could do a command show CDP neighbors, and then you see that we've only got one device, R2, and if we do show CDP neighbors details or detail, you can actually see that the device is a Cisco device with the IP address at 10.1.2.2. So based on that and what we know about the environment, it's probably going to be this R2 router in the environment. Okay. Now, if we jump onto R2, I'll just clean the terminal, and we start off a similar sort of process. So if we do show IP root 10.200.200.50, we can see that we actually, oh, that's followed the default route because I've done a typo. If we go 10.200.200.50, I'll just get a few lines there and do that again, so we've got a clean output. We do have a routing entry for 10.200.200.50. Again, it's on a /24 10.200.200 network, and it's being learned by OSPF1. It's an intra-area route, and if we do show IP route, we can validate that and also validate that we have 10.200.200.0 and the next hop is 10.1.11.1. So if we do show IP route 10.1.11.1, we can see that it's directly connected out of interface 1/3. Show run in Ethernet 1/3, and we can also see that 10.1.11.2 is this IP address, and just another validation to show IP interface brief. We've effectively got two IP addresses on this device, or a few different IP addresses, but actual interfaces, you can see that we've got routable interfaces. We've got 10.1.2.2 and 10.1.11.2. We know that 10.1.2.2 goes back to router 1, which is .1. So by process of elimination, I'm going to guess that R3 switch is the next hop address towards 10.200.200.0. So if we go on to this switch, which is actually an Arista switch, I'll clear this, and we what the question would be, if you remember the task in hand, we want to identify what device is 10.200.200.50. So if we were to say what is 10.200.200.50, and we do show IP ARP first of all, because this is a switch, we can see that we actually do have an entry for 10.200.200.50, which is on VLAN 10 and port Ethernet 9. So if we do show run in Ethernet 9, we can see it's very simple. Switch port access VLAN, it's in VLAN 10, and then if we do a show MAC address table, we can also see that we have Ethernet 9 has a MAC address of this, and it's a dynamic MAC address and various different things. The final part of the puzzle, so what we're basically saying there is, if we were to look at this topology and determine, remember we're trying to determine what 10.200.200.50 is on the network. We've determined where it resides by following the routing table from R1 to R2, then to R3, where we've checked the ARP table, the IP ARP table, and then the MAC address table, which has then pointed us in the direction that we are connected to Ethernet 9 interface. And that's how we've achieved that, or we have achieved that by tracing through the network. I'm going to give the game away just in the interest of time for the video, but if I switch the interfaces on GNS3, you can see here that indeed it's the LXLE host here that is in Ethernet 9. So if we cross-reference the MAC address here, so this is the MAC address that we're looking for. If I go to this LXLE host and open the terminal and do an if config. We should have the MAC address here and the IP address. So we have 10.200.200.50, and then our MAC address should be here somewhere, OC62 OC480000. So you can see in this host down here, LXLE host, it's connected on Ethernet interface Ethernet 0. And this is it down here, and it connects to Ethernet 9 on the switch, and that is how we would potentially track down a host on the network. Just to give you another example of the types of things that we're looking to do, you can actually see here that we have another task in the list. If I jump down to this one, which is task 5. So validate there is web access to router 1 on port HTTP port 80 from the CLI on R2. So on R2, what we're trying to do is like see if we can browse to the web interface of this router from R2 to see if like the IP HTTP server functionality is operational. And the reason that I want to show this will be a bit clearer after I actually do it. But how we could actually achieve this is if we telnet to 10.1.2.1 and then type 80, which is the HTTP or port 80, we can telnet to that and we see that the session is open. So that says that we do have web access to R1 on port HTTP/port 80, and we can also validate that in the session here. If I just close this down and we go to 10.1.2.1 with HTTP, you can see that I can access the web interface of R1's router. Okay, so this is what I'm thinking about we could potentially do. These are real life things. Just to put that into a use case, if you're working in a data center environment and there's virtual machines and the team is reporting to you that they've got their Apache server up, and this is where I was working on the next part of the training, is enabling Apache on an Ubuntu host. Let's say that this server down here, or this client, is running an Apache server, and you're coming in from like the WAN or the internet and you're routing down here and they say the network isn't working. But you can actually check, you might do this check from a network device, like so telnet to this client, or in this case we telnetted to this R1 router, but on port 80. So we can see, if I've had scenarios where all the VLANs are plumbed down to the device, all the routing is in place, but you check and there's either like a firewall or the server is not listening on port 80, even though the Apache service is installed, it's not actually activated and things like that. So these are some of the things that I'm thinking about putting a course together for. It's really to give real life examples of what we can do in regards to network troubleshooting, and this feeds into network discovery. So if you're given a picture with no information or validated configurations, you might need to be able to find your way around the network and validate different things. Let me know what you think, if this is something that you'd be interested in, and thanks for your attention.